Hello everyone, welcome to YouTube channel Learn with Gisla. This is the fifth part of the chapter Squares and Square Roots, where we are going to learn about two cases of long division method. In the first case, we have to find the least number which must be subtracted from the given number to make that number a perfect square. And in the second case, we have to find the least number which must be added to the given number to make it a perfect square. Now in first case we have to find that number what should be subtracted. In the second case we have to find what should be added to the number to make it a perfect square. Now in both the cases the number given to us is not a perfect square number. That's why to make it a perfect square number we have either to subtract a number or add a number depending on the question what is asked in the question. We cannot use prime factorization over here. There were different cases of prime factorization where we were asked what should be multiplied or what should be divided. Because over there we were given the product of the factors. So there we had two cases of multiplication or division. But over here by using long division method we can find out the least number which can be subtracted or added from the given number to get a perfect square number. So that's why it is called two cases of long division method. Now what is long division method that we have already discussed in the previous video, but still let me take a question to quickly revise it. So the question says find the square root of 4401604 by long division method. So first of all we will start forming the pairs from the ones digit. These pairs are also called as periods. So first period is 04, then we have 16, then 40 and then 4. Now we shall take the leftmost period, that is 4, and we will think of the largest number whose square is either less than or equal to 4. So clearly it is 2. We know that 2 into 2 is 4. So we will write over here the product 4 over here and further find the difference. 4 minus 4 is 0. Now bring down the next period, that is 40. This is our new dividend which we have to solve. For solving it we need a divisor. So over here the first quotient is 2. We shall double it. 2 into 2 is 4. Now to get this 4 we can also add 2 over here because the new quotient was 2. So 2 plus 2 is 4. So that's how also we can get this 4. Now leave a blank space over here next to 4. Now there is a blank space over here next to 4. Which number should come over here and the same number will become the quotient so that the product which we get should be equal to or less than 40. Now naturally it is 0 if I keep, I'll get 0. If I keep 1 over here and multiply by the same number 1, I will get 41. So over here 41 is greater than 40. I cannot take 1 over here. So I have to restrict myself to 0. So divisor becomes 40, quotient becomes 0, product becomes 0. Now 40 minus 0 is 40. Bring down the next period, that is 16, and my new dividend is now 4016, for which I need a divisor. Now again for divisor, I will see my quotient. Quotient is 20. I will take this quotient down. I will double it, make it 40, leave a blank space. Or my divisor was 40. I can just add 0 to it and I can get 40. That way also we can do. Now we have 40 over here. We have a blank over here. What number should come over here so that the product also with the quotient, if I multiply, I should get a number which is less than or equal to 4016. So by trying 8, 9, I'm getting 3681. So I think this is pretty closer to 4016. I cannot keep 10 because that will become 40,160, right? So I will stick to 9. So my divisor becomes 409. My quotient is 9. And over here my product is 3681. And the difference is coming 335. Now bring down the next period, that is 04. So my new dividend now is 33504. for which I need a divisor. So for divisor, I can take the quotient. First of all, quotient is 209 now. Let me bring down 209 now and double itself. And it will come 418. Leave a blank over here. Or 409 was the divisor. 409 was the, just add 9 to 8 and you will get 418. So that is also one of the method. Now 418 and a blank is there. What should what number should come over here, and I multiply by the same number so that I can get a product which is exactly equal to or less than um, this number 33504. So clearly it is 8 which I can take. So my new divisor is 4188 multiplied by 8. I get the product 33504, and when I find the difference I get 0 as the remainder. So 0 is the remainder. There is no more period also left over here which I can bring down. So I can say the quotient which I have got over here, the quotient which I have got over here is my square root of this number. So square root is 2098 of 4401604. Now one thing you have to note over here is number of digits in the square root is exactly equal to the number of periods which we formed in the beginning. So over here number of periods were 4. So exactly we will get number of digits in the square root will also be 4. So this is important point to note over here. So I hope now the long division method is clear to everyone. Let us move to the two cases where we are going to use long division method. Now let us start with the first case where we have to find the least number which must be subtracted from the given number to make it a perfect square. Now the given number is not a perfect square. That's why we have to find that least number, what should be subtracted from it, from the given number to make it a perfect square. So we will use long division method to find out that least number. Let us take up the question. Find the least number which must be subtracted from 5607 to obtain a perfect square number. Find the perfect square and its square root. So this is the number which is given to us, 5607. It is not a perfect square number. To make it a perfect square number, we have to find a least number which we will subtract from this number to get a perfect square number. After getting perfect square, we have to find its square root. So we are going to use long division method to solve. First of all, we will start by forming the pairs from the ones digit. These pairs are also called periods. So first period is 07, second period will be 56. Now we are going to take up this 56 and think of the largest number such that its square is either less than or equal to 56. So clearly it is 7. 7 into 7 is 49. 8 into 8 is 64, which is more than 56. So we shall restrict ourselves to 7. So 7 into 7 is 49. 49 is the product which we have got. Now 56 minus 49 is 7. Further bring down the next period, that is 07. So 707 is the new dividend now. We have to think of the divisor now. So what we are going to do is take the quotient and double it. 7 into 2 is 14 and put a blank over here. Now think of a number what should come in this blank 14 in and next to 14 so that it is equal to or less than 707, so that the product is either equal to or less than 707. Now I have taken 4 over here and it has come 576. Let me show you, if suppose I would have taken 5 and I multiply by 5, 5 into 5 is 25, 4 into 5 is 20, 22 and 725. 725 I am getting, which is more than 707. So clearly my divisor will be 144 and quotient is 4 and my product is 576, which is less than 707. And further, when I find the difference, I will get the remainder 131. Now I have no more period left over here. I have a remainder 131. So basically why this remainder has come, because while finding the square root of 5607, this is something which is extra included in this. That's why it is not a perfect square number. So we conclude that 131 should be subtracted from 5607 to make it a perfect square. Now how to get a perfect square? When we subtract 131 from 5607, we get 5476. Now this is a perfect square number and square root of this number is 74. Even if we have to check it, we can check it. If we have to check over here, we can find the square root of 5476. Let us check. So first of all, form the pairs, and then 7 is the closest number which we can use over here. Further 14, and suppose I take 4 over here, so I'll get exactly 576, and the remainder is coming 0 over here. If I subtract it, remainder is coming 0. So over here you have observed that exactly 74 is the square root of 5476. That means from 5607 we subtracted 131 to get a perfect square number, that is 5476, and square root of 5476 is 74. Now let us take up second case where we have to find the least number which must be added to the given number to make it a perfect square number. Now this given number is not a perfect square number, so we have to find that least number that will be added to this given number so that it becomes a perfect square number. For this we are going to use long division method. So let us start with the question. Find the least number which must be added to 5607 to make the sum a perfect square number. Find the perfect square and its square root. So as you can see, I've taken the same number 5607 which I have taken in case 1. In the case 1, they had asked us to find what should be subtracted from this number to make it a perfect square number. Whereas in case 2, they are telling us to find the least number which should be added to this number so that the sum becomes a perfect square. And after getting the perfect square, we also have to find the square root of the number so obtained. So now let us start with the long division. Same process we will continue as we have done in case 1. So we will take the number 5607. We will make pairs starting from 1's digit. These are also called periods. So now the closest number is 7, whose product, or you can say whose square, is closest to 56. It is either equal or less than 56. So 7 into 7 is 49. 56 minus 49 is 7. Further bring down the next period, that is 07, and we get the new dividend, that is 707. Now we want a divisor. So for that we'll take the quotient and double it. 7 into 2 is 14, or we can just simply add 7 to it and we will get 14. Now add a blank over here. What number should come over here so that we multiply by the same number and the product is actually less than or equal to 707. So let us take 4. So this is the number 144, which is the divisor, and we shall multiply by 4. We shall get the product 576, which is closest to 707, and we get a remainder 131. Now since we get a remainder, so we know that 5607 is not a perfect square number. And if we have to subtract a number, so to make it a perfect square, we will subtract 131 from it. But over here in this question, they have asked us to find a number which should be added to this 5607 so that the sum becomes a perfect square. So as you can see in this first line over here, we observe that 74 square is 5476, which we had calculated in the previous case, case 1. 5607 is greater than 5476. Now we need a number which is a next perfect square number. So that number we can try with 75, because after 74 the next perfect square number we can get with 75. 75 square is 5625. So a number which is more than 5607 is 5625. So basically from 5607 we subtracted some number to get 5476. We subtracted a number. Now to get another perfect square number, we have to add some number, right? We have to add some number. Now how to find that number? So we shall do the long division process, but with the next square number. So instead of 4, now we will take 5. So 145 into 5, we will get 725 over here. And the difference between 707 and 725 is minus 18. That means we are falling short of 18. Had 5607 be 18 be added to 5607, we would have got a perfect square number, that is 5625. Over here you can see, if we add 18 to 5607, we get 5625, and 5625 is a square number of 75. So clearly we can say the square root of 5625 is 75. Now we can check also. We can check by using long division method. Suppose we take the number 5625, make the pairs as we do in long division. So 25 and 56 are the two periods we have got. We'll start with 7 because 7, the product is closest to 56. Further we will get 725, and we shall try with 5 over here. Sorry, 25, 725. Subtract it, we'll get 0. Now see, from the remainder is coming 0 over here. That means 5625 is a perfect square number whose square root is 75. Basically it is a square of 75. So this is how we have solved the second case, and we have found the number what should be added to the given number to make it a perfect square number. So 18 was the number which we had added. Okay, so this is clear. Now let me explain both the cases together. So the same number 5607, we have to take this number and see what should be added to this number and what should be subtracted to this number so that it becomes a perfect square number. So in case 1, we have to find out which number should be subtracted. So for that we will solve 5607 by long division method. We shall get the remainder 131 with the quotient 74. That means 131 is extra over here, which we can subtract from 5607. So we can subtract 131 from here, from 5607, and we can get 5476, which is actually a square of 74, right? So square of 74 is 5476. So this, what we subtracted the remainder. So we can say over here 131 should be subtracted from 5607 to make it a perfect square. So the perfect square number so obtained will be 5476. Now square root of 5476 is 74 because 74 square was 5476. We have seen over here 74 square is 5476. Now 5607 is greater than 5476. Now the next case is what should be added to it. So if we add something to 5607, it will become something more. It will turn into next square number. And how to get a next square number? Basically we have 74 right now. So next square number will be 75 square. If we do 75 square, we should get 5625. That means to get 5625, we have to add something to 5607. Now what is that something, what we should add it? How much extra we require? So for that we will again do long division process. But over here, instead of 74, we will take 75, right? And we will get minus 18. Minus 18 is something which is we are falling short of. Had we add 18 to 5607, we will get a perfect square number. Like see over here, 5607 plus 18 is 5625. So it is a perfect square number. It is square of 75, right? So we can say square root of 5625 is 75, right? So again, I'll just show you that 5476 is a square number which we have got after subtracting 131 from 5607, and 18 is the number. 18 is the number which we added to 5607 to get 5625, which is another or you can say the next perfect square number after 5476. 5476 was a square of 74 and 5625 is the square of 75. So now I hope everyone has understood these both the cases properly. Yes. So this is it. Hope you have enjoyed the video and learned the two cases thoroughly. Please do like and subscribe my channel. Thank you everyone. Have a good day ahead.